So let's do a bunch of questions. First question. I'll write it down and then I recommend you pause the video, have a go in your own time, and then you can see what I've done. I'll number the questions. Okay, what's my answer to that? Well, something times something is 9. Oh wait, well 3 times 3 is 9. So that's one possible answer. And also minus 3 times minus 3 is 9. So that's another possible answer, which means that x equals 3 or minus 3. You might have done that a different way. Maybe you did this. Maybe you did x plus 3. Maybe you factorized it. I would say this is the best way to answer the question. And then you can say you've just factorized it. There's two things multiplied together. So that means one of the two things must be equal to 0, because remember there's a times sign in there. So that means that x plus 3 equals 0. Or x minus 3 equals 0. Which means that x equals minus 3. Or, because that vertical line kind of means or, x equals 3. Because in those two cases I've rearranged. On this left hand side I've minus 3 from both sides, and on the right hand side I've added 3 to both sides. Let's do the next question. Shifting that out of the way slightly. Question 2, if I can find it, is 1 over x plus 1 over 3 plus 1 over 3 equals 1. Pause the video, have a go in your own time. When you're ready, come back. Okay, so my answer is, well, I'm just going to, first of all, let me just do this. I won't keep doing this, but as this is the first one in this video, an x can just be thought of as a gap. There's like something that has to go there. Oh well, that has to be 3, which means that x equals 3, because a third plus a third plus a third equals 1. Let's do the next question, number 3. Here we go. Have a go in your own time. Pause the video to have a go in your own time, and then come back when you're ready. Well, the square root of something is 25. Well, do you know what? Right, well, the way I'm going to do this is I'm going to square both sides, which means that I get the square root of q squared equals 25 squared, and the square root and the squared cancel, so that just means that q equals 25 squared. So I'm going to have to work that out now. Oh no, this is horrible. 25 times 25, right, 5 times 5 is 25, 2 5s are 20, well that's 20 times 5, so that's 100, plus 100, and what's 20 times 20? That'd be 4, tell me if I got this right, I'm pretty sure that's 400. I'm terrible at doing maths like this, I normally use a calculator, so the way I'm going to double check that is, I'm going to go 20, 20, 20, 20, 20, so that makes 100. Yeah, so then if I have another 5, plus another 5, then plus another 5, and then that makes 400. Yes, that's correct. Which makes 4, 5, 625. So Q equals 625. Let me just shift that up slightly. So that's the answer to that one. Notice I didn't change the colour of the pen. Oh well. Question number 4. 5 plus x times 2 equals 0. Have a go in your own time by pausing the video, come back when you're ready. Right, there's lots of ways of doing this. I'm first of all going to do it kind of by inspection. So I'm going to say 5 plus something times 2 equals 0. What would that something have to be? Well, they've got to cancel because it makes nothing. So that would have to be minus 2.5. So that means x equals minus 2.5. So that's the answer. Now, I don't think that's the best way of doing it. From a kind of technical maths point of view, if you're kind of aiming towards eventually doing like a degree in maths or something, in which case it would be better to do initially simplification. So 5 plus 2x equals 0, then we're going to minus 5 from both sides, so 2x equals minus 5, and then I'm going to divide both sides by 2, which means that x equals minus 5 over 2, which obviously is the same as minus 2.5, and generally I always say that leaving your answer as a fraction is better than turning it into a decimal. Oh, and I keep dragging it out off the page. If that's catching you unawares, remember you can always just rewind slightly the video if you wanted to see the working. Here's the next question, number 5. Have a go in your own time by pausing the video. Okay, right, well, this is another solve question. I think I didn't say at the start of the video these are all solve questions, but it would have said in the title of the video. Well, C is obviously 3, so that's easy. Well, we obviously need to find out what A and B are. So we've got A plus B equals 5. I'm literally rewriting A plus B equals 10. I'm literally rewriting that. There's no benefit. And then I've got A plus B plus 3 equals 0. So if I then minus 3 from both sides, I get A plus B equals minus 3. Okay, what does that tell us? We've got two things that contradict. A plus B, if we're just kind of using real numbers and all that kind of stuff, cannot be simultaneously equal to 10 and equal to minus 3. Therefore, not possible. So we can't answer that one. It's not possible to find an answer. We do know what C is, but A and B... Well, do we know what C is? I mean, maybe there's a mistake in the question, but assuming... Okay, let's not get into the philosophy of this question. It's not possible to solve this question for A, B and C. let's just call it a day on that. Question number 6. X plus open bracket x plus x close bracket equals 80. Have a go in your own time by pausing the video. Come back when you're ready. Right, can we ignore these brackets? We can. Why can we ignore these brackets? Because we're just adding stuff. And if you're just adding stuff, or if you're just timesing stuff, and it's just a list of individual things, then you can ignore the brackets. It depends, you have to be careful. But in this case, you can definitely just ignore the brackets. Do you know what? Let's pretend we didn't know that. Then we'd have to multiply the brackets out. Okay? So you've got x plus x, obviously, because we've just written down the left-hand side. What's plus times x? Well, it's just plus x. What's plus times plus x? Well, it's just plus x. There you go. So you could also do it like that. Ah, so 4x equals 80. Divide both sides by 4. X equals 20. Boom. Let's do the next question. Question 7. X squared plus x squared equals 0. Pause video, have a go in your own time. Well, I could simplify that as 2x squared equals 0, because we're always trying to simplify. When we do maths, at every opportunity we try and simplify. An opportunity to simplify is an opportunity to make the question easier, and maybe an opportunity to instantly find a solution. In this case, I'm now going to divide both sides by 2, which means that the 2 just literally disappears, which now means that x equals 0. Do we write or minus 0? Well, according to me, minus 0 doesn't exist. So therefore, it's just 0. Technically, one could say it is a repeated root. If you're getting super advanced and you want to get... hang on, let me just... repeated. Technically, it's a repeated root. If you're getting super advanced and technical. But, I mean, that's not really that important. Unless you're doing, like... trying to get a high grade at A-level or at university. At least at the time of writing this, because students seem to just keep doing more and more advanced things. Anyway, PQ equals 0. That's your next question. Have a go in your own time by pausing the video. Okay, we've got two things multiplied together that make 0. The only way that can be possible if one of them is equal to 0. So P equals 0 or Q equals 0. Or P equals Q equals 0, because they could both be 0 in this case. So is that the neatest way of writing it? Well, you could also just have said p equals 0 and or q equals 0. Let's just reiterate this. For two things multiplied together to make 0, one of them has to be 0. What's 5 times 2? Do you know what, I'm going to do this in a different colour so it's not too confusing. What's 5 times 2? It's 10. What's 1 times 3? That's 3. What's 0 times 3? Oh, that's 0, look at that. What's minus 3 times 0? Well, that's 0. And by the way, what's 0 times 0? Well, that's also 0. So the point is, for it to be equal to 0, there has to be a 0 kicking around in there. One of the two has to be a 0. Let's do the next question. Question number 9. That is a number 9. That is a letter Q, in case you're wondering. Have a go in your own time. Right, again, let's look at this two different ways. Well, that's just 3 to something, because that Q is the unknown, so we just write a box because we don't know what it is. So what goes in that box? Well, the number 2 does. So Q equals 2. How else could we answer that? We want to get the Q on its own. Let's not go there. There are ways to do that. Something to do with logs. There's another way of solving equations, which is you try and make things look the same. Make it look the same. So on the left hand side we have 3 to a power, and on the right hand side we just have a number. So why don't we make both sides look like 3 to a power? 3 to the Q equals, how do we write 9 as 3 to something? Well, that'd be 3 squared. So now we can say, now we can say by inspection, that's our technical maths language, Q must be equal to 2. Arguably I've just done exactly the same thing and just written it differently. But we're looking at ways of thinking, approaches, ways that the solutions come into our minds. Question number 10. Oh, and in case you hadn't already realised, I haven't really said this yet, you might be solving these questions a different way. It doesn't matter. I'm just giving you some thoughts on how I would do it. And generally speaking, yeah, but have a go in your own time. Well, here's the first thing. X is obviously equal to 100. Well, because the square root of something times the square root of something is just itself. But suppose we didn't realise that, and suppose what I just said doesn't make any sense to you, which is fine, then we can say, right, well, what's the square root of 100? Oops. Well, that's 10. What's the square root of 100? Well, that's 10, which equals x, and there should be a times sign in the middle, because remember there's a times sign in there because the times sign is the only symbol in maths that has an invisibility cloak, so you can't see it. What's 10 times 10? It's 100. Oh, equals x. There you go. Question 11. If I can just find it on my piece of paper. Here we go. Y divided by 5 minus 2 divided by 5 equals 1. Have a go in your own time by pausing the video. Well, we could just do it with a box. Let's just do that. And then we can just use our intuition. Must be 7. Y has to be 7. Because that way, 7/5 minus 2/5 is 5/5, which equals 1. Let's just write that down. 7/5 minus 2/5 is 5/5, which equals 1. If you don't believe me, what about elephants? 7 elephants minus 2 elephants, because we're using fifths in the question, but why don't we just use elephants? Well, how many elephants is that? That's 5 elephants. There you go. So hopefully that convinces you that it makes 5/5. And 5/5 happens to be the same as 1. Well, obviously 5 elephants isn't equal to 1. Well, it depends on the elephant, I guess. You could have done this by rearranging. Should we do that or not? What do you reckon, guys? Let's just briefly do that. In which case, let's just move that up slightly. Let's add 2/5 to both sides, which means that y over 5 equals 1 plus 2/5, which equals 7/5. Oh, look at that! We can now use by inspection. Remember the by inspection thing? That's where we say everything is so similar, we've made it look the same, that by inspection, obviously, that must be the same as that, so y equals 7. You could also multiply both sides by 5 to get rid of the 5, and they would have also ended up with y equals 7. Question number 12. Let me just find the question. Here we go. A plus B equals 5. Pause the video, have a go in your own time. Maybe you wrote A equals 2, B equals 3. Now maybe I've seen students do this, right? A equals 1, B equals 4, A equals 3, B equals... By the way, this is not going to a good place. And then a student will say, oh, there's only 4 possible answers. Well, I might say 6 because B could be 0. And then A could be 0. Anyway, point is, wait a sec, what if A is minus 1 million? And then B would be, well, yeah, B is minus 1 million. Then that would mean that B is 1 million and 5. Do you see where I'm going with this? There are an infinite number of solutions. So we could just say there are an infinite number of solutions. But my recommendation is to say, in the context of this set of questions, bearing in mind how advanced we're going with some of them, I think probably the correct answer is just say not possible. It's not possible. And you could say because there are an infinite number of solutions. Question 13. X squared minus 9 equals 0. Pause it, have a go in your own time. I'm going to show you what I think is the best way to do this. It's a quadratic. Therefore we factorize, because that's how we solve quadratics-ish. But broadly speaking, that's what we do. Now we factorize, we have two things that multiplied together make 0. As we've been discussing a bit, that means that one or the other must be equal to 0. So I'm going to minus 3 from both sides here, so x equals minus 3. We're going to add 3 to both sides here, so x equals 3. And we write or. By the way, notice that we didn't write and or. The reason is x can't be minus 3 and 3 at the same time. Unless you're doing some really weird theoretical maths, I guess, but I'm not aware of how you can do that. So I might have been tempted to do this. No, do you know what? That's absolutely how I would have solved it. Maybe you did this. Maybe you added 9 to both sides, which means that x squared equals 9. And then you just, you might have written this in a circle, square root, and you say x equals 3 or minus 3. Or you might have written x equals plus or minus 3. I always like to write or. I think or is a good word to write. Because it's clear. It shows exactly what you're doing. Question number 14. This is, I would say, an unusual question in the context of all the other questions we've looked at so far. Have a go in your own time. Why did I just say it's an unusual question? Because I think this is a very orthodox question. It's a very normal question. It's not strange. All we do is rearrange it. It's an x on its own. There's nothing else. There's no other unknowns. There's not an x squared or anything. So we just need to get x on its own. That is the approach to solving this kind of question. So let's push everything away. The first thing, if you're not sure what's maybe right, you move the 11 first. If you weren't sure, I always say imagine it's on a piece of paper and you shake the piece of paper. What's going to fall off first? That 11 is going to fall off first because it's the most perilous. It's not connected very well to anything else. Anyway, there's loads of other ways to think about it. That's probably not the, well, it depends. Anyway, times 11, x minus 5 equals 22. Now we're going to move the 5 over to the other side, so we're going to plus 5 to both sides, so x equals 27. That's it. Boom. See what I mean? It's quite an orthodox question, really. Question 15. So I just need, in case you're wondering, I'm looking across at a piece of paper where I've scribbled down lots of ideas and then I numbered them off. Right, here we go. So sometimes it takes me a moment to find the one with the correct number. Have a go in your own time by pausing the video. Right. This kind of resembles one we've done before. One option is just to put a box in, and I don't personally write a box myself because I'm so used to the idea that x just represents something that when I see x, it's just in terms of, like, I call it matrix maths, if you've seen the film The Matrix, where Neo eventually learns to realise that nothing truly exists. So it's like x doesn't truly exist, it's just a placeholder for something else. So matrix maths, we go, x doesn't really exist, so we just allow our mind to visualise what could be there. Oh, x is obviously I think it's 4. Let me check. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Yep. That's good practice to write that out. If I was in an exam, I'd always double check. There you go, so x equals 4. How else could we do that? Do you remember the thing where we said make both sides look the same? So you could say 2 to the x equals, that would be 2 to the 4. Then we can say by inspection, x equals 4. And I'm not looking at other methods involving things like logs because it doesn't feel like the right thing to be doing for this video. Question 16. Square root of y, square root of x equals 9. Have a go in your own time. And that is a number 9, by the way. That is a letter x, that is a letter y. Answer is not possible. You might be familiar with the idea that root x, root y, root x is root yx, which I would write as root xy because it bugs me. I always like things in alphabetical order because then you have it consistent all the time and then it's easier to spot patterns. Anyway, so then you could say that square, just in case you don't quite believe me, you're like, well, are you sure you can't solve it? So then you could square both sides. So I'll just put a squared in a circle, and then that means that xy equals 81. Clearly, x and y could be anything. Well, do you know what we could? We could say x is not equal to 0, y is not equal to 0. We know that. So that's our limited knowledge of x and y. Otherwise, we have no idea what they are. Maybe I've missed something. Maybe there's something else we know as well. Well, the thing is, you could start listing things, but we already have. Here's the thing: you might go, oh well, but we know that x is 81 divided by y. But I would argue that's just a restatement of this condition. But at least by writing this, we kind of have a second condition, because we're saying due to our knowledge of zeros, I can conclude that x isn't 0 and y equals 0 isn't 0. Let's do the next question. Apologies if that got too complicated, don't worry about it if you didn't really understand what I was just saying. A over b equals 3. Have a go in your own time. Right. A possible answer would be, for example, perhaps it's 12 divided by 4, which means that a equals 12 and b equals 4. But we have the classic problem here, which we've already talked about, which is a and b could be anything. So there's an infinity of answers, so we just say not possible. Now, I kind of went off grid, to use a strange English phrase. I went off the what's it called when you have a when you have a ranch in the States and you go off of the ranch. God, it's not, anyway, doesn't matter. Anyway, I went crazy in the last one. So, do you know what we could do? Is we could say b isn't equal to 0. But here's the problem. Highly technically speaking, and in fact maybe this is right, hang on. Let's talk about this. What if a is 4 times b, is 3 times b, and a is 0? Well then b is just a 0 that is 3 times as large. So here's the problem, we're getting into philosophy now. When you start talking about zeros and infinities, basically you're entering philosophy and not maths. So should we just say not possible and just leave it at that? Is that a deal? Okay. In which case, can we just go back here? Technically, one of x or y could be 0 if the other one is infinity and the infinity and the 0 interact possibly. So do you know what? I've changed my mind. Let's get rid of that. Let's just not go there. Let's just say it's not possible, yeah. So we said for question 16, because remember we've just come back to question 16, we're saying that question 16 wasn't possible. Question 18. X squared equals 0. Have a go in your own time. Welcome back. X equals 0, because you just square root both sides. The square root of 0 is 0. And you might say repeated roots, or repeated root. It's debatable. It's really not that important. But I just said it in case you wrote that down. You're like, Duncan, I thought it was repeated root. And yeah, technically it is, but we're not worrying about that in this video. Have a go with the next question. That is a P. Letter P, that is a letter Q. Answer. Well, I actually wrote this wrong by accident, but it's fine, because it's teaching something else. It's not possible. Why is it not possible? Because there's no equals sign. Where's the equals sign? There is no equals sign. I actually meant to write an equals there somewhere, but it doesn't matter. This is a different question. It's still interesting. This is not an equation. And therefore we can't solve it. It's just a statement. It's just a value. So yeah, you can't learn it. There's nothing you can do. Which means it's not possible. Question 20. That is a letter, and it's the letter Q. Have a go at solving this in your own time. You might have come up with an answer to this, but in fact the answer is not possible. Because Q could be anything. What's 1 to the 7? Well, that's 1 times 1 times 1 times 1 times 1 times 1 times 1, which is 1. So it doesn't matter what Q is. Q can be anything. Q equals anything. Ish. Can it be a fraction? Yeah, I think it can. Actually, I think it can be anything. But let's move on. That is square root of x equals 9. Have a go in your own time. We could square both sides. Well, the first thing is we can just do it by inspection. X is obviously 81. Because the square root of 81 is 9. But if you didn't see that, you just do the same to both sides, and we want x on its own, because x is there. So what do we do to get rid of the square root? We do the opposite. The opposite of that is squared. So we end up with x square root squared equals 9 squared. The square root and the squared cancel, so you end up with x equals 81. Question 22. Okay, have a go in your own time at this question. I'm going to do it by inspection. D must be 5, because a half plus 5 over 2 is 6 over 2, which is 3. But we might have minus a half from both sides, which would give us d over 2 equals 3 minus a half, which means d over 2 equals 5 over 2, times both sides by 2. Let's just be super thorough here, even though we could do it by inspection already now. D equals 5. Ooh, what number was I? 23. A minus b equals 10. A equals b. Have a go in your own time. I think this is difficult. I mean, it depends on. Let's take this one here and let's add b to both sides. That means that a equals b plus 10. Right. Have you spotted the problem? Here's the problem. These two contradict each other. They can't both be true. So it's not possible. Or you could say there are no solutions. 24. x minus 12 squared equals 0. Have a go in your own time. Right. Here's the thing. There's multiple ways of doing this, and you probably think about it different ways. I would say the important thing, going back to the matrix maths again, when I see a squared, I try and visualize. So if I see x squared, let's not use x. If I see k squared, in my mind I'm seeing k times k. That's what I'm seeing. Because it's so important to be kind of visualizing what the squared means. So in reality, this is what the squared means. Oh look, it's just two things multiplied together. So x minus 12 equals 0, or x minus 12 equals 0. Oh wait, that's exactly the same thing, so you don't need to worry about that one. Add 12 to both sides, x equals 12. And you could say, if you like, repeated root. Again, if you don't know what that means, don't worry about it, doesn't matter. I'm just saying that because that's like a more advanced thing that some people have been trained to do, and that is correct. And if you don't write that in more advanced exams, you lose a mark. Have a go at this in your own time. What's root 2 times root 2? That's 2. What's root 2 times root 2? That's 2. I'll stick a times sign in there. Because you don't need a times sign between square roots, but you do need it between numbers. Which means y equals 4. And that just bugs me, I'm just going to write it around the other way. There you go, that's it. 26. X to the n equals 25. Have a go in your own time. Maybe you wrote 5 squared equals 25. And so you said, well, x equals 5, n equals 2. What's the issue with that? Is that correct? On its own, that's correct, but it's not correct to say this is the answer. It's only one of an infinity of possible answers, so I would just say not possible. So if you just saw that and looked, oh, there's two unknowns, I've only got one equation, I can't solve it, and you just wrote not possible, that's correct. If you wrote one possible answer down and kind of claimed that that was the answer, then that's wrong, because that's not the answer, it's just one of many possible answers. Hopefully you enjoyed that video. Leave comments, all that kind of stuff. This, in case you're interested, this is my first video that I've made for about 2 years in maths, and let me know if you like me putting maths videos. I might make some more. Blah blah blah, whatever. Anyway, leave comments if you've got any questions.